The factors that drive scientific progress. What are the key factors that accelerate scientific progress? What can push thousands of scientists to create something that seemed impossible just a few decades ago? Historically, two main drivers have played the most significant role: war and politics. These forces, for better or worse, have shaped the advancement of space exploration. Today, we will discuss 10 fascinating facts about the history of space exploration. From ancient times, the sky has fascinated humanity. During the day, people dreamed of soaring like birds, and at night, they gazed at the stars, wondering about their meaning. Early civilizations discovered that celestial movements corresponded with seasonal changes, leading them to believe that the heavens influenced earthly events: wars, famines, epidemics, and even the fate of kings. This belief system greatly contributed to the development of astronomy, as it provided a practical reason for rulers to fund celestial observations. Ancient astronomers from Babylon, Egypt, Greece, and China made significant discoveries. For instance, the Greek scientist Eratosthenes calculated Earth's circumference with remarkable accuracy using simple tools and geometry. His estimate was only 545 kilometers off the actual value. Over time, curiosity about the cosmos never faded, even in the face of wars, plagues, and religious opposition. The work of Copernicus, Cassini, Kepler, Newton, and Lomonosov forever changed our understanding of the universe. The birth of space exploration. The idea of space travel emerged when the heliocentric model of the universe was widely accepted, proving that planets were similar to Earth. The question remained, could humans ever reach them? One of the earliest visions of space travel came from science fiction. In 1865, Jules Verne published From the Earth to the Moon, describing a mission where astronauts were shot into space from a massive cannon. Though unrealistic due to the lethal acceleration forces involved, the novel inspired real scientists and engineers to consider the feasibility of space travel. As technology progressed, rocketry became the focus of scientific exploration. At the turn of the 20th century, a network of researchers across different countries began studying interplanetary flight. One of the pioneers was Konstantin Tsiolkovsky, a self-taught Russian scientist. He not only worked on the technical aspects of rocketry, but also explored the philosophical implications of space colonization. He formulated the fundamental rocket equation and identified liquid hydrogen as the most efficient fuel for space travel. His vision laid the foundation for modern astronautics. Another key figure in rocketry was Hermann Oberth, who demonstrated the possibility of achieving orbital speeds and leaving Earth's atmosphere using existing technology. His research proved that humans could survive the intense forces of space travel. The rocket age begins. The 20th century saw the first major advancements in rocket technology. One of the most influential engineers in this field was Wernher von Braun. During the 1930s, he worked on developing powerful rockets in Germany, which were later used in World War II. The V-2 rocket, developed under his leadership, became the world's first long-range ballistic missile. While initially designed for warfare, these rockets also laid the groundwork for space exploration. As the war ended, both the Soviet Union and the United States rushed to acquire German rocket technology. In the U.S., von Braun and his team played a crucial role in advancing America's space program, while the USSR developed its own rocketry based on captured V-2 designs. One of the leading Soviet engineers was Sergei Korolev, who had been imprisoned during Stalin's purges but was later rehabilitated to spearhead the Soviet space program. Korolev's work led to the development of the R-1 rocket and eventually the legendary R-7, the rocket that would launch the first artificial satellite, Sputnik 1, into orbit on October 4, 1957. The entire world heard its signal, marking the beginning of the space race between the USSR and the USA. The race to space following Sputnik's success, both superpowers intensified their efforts to achieve human spaceflight. The Soviets continued with animal test missions, launching dogs into orbit to study the effects of weightlessness. One of these missions, involving the dogs Belka and Strelka, provided valuable data proving that living beings could survive extended periods in space. The next step was inevitable, sending a human beyond Earth's atmosphere. In 1961, Soviet cosmonaut Yuri Gagarin became the first person in space aboard Vostok 1, completing one orbit around Earth in 108 minutes. This historic flight demonstrated that humans could endure space conditions and return safely. Soon after, the Soviets sent the first woman into space, Valentina Tereshkova. Meanwhile, the United States was determined to catch up. NASA launched the Apollo program with the ambitious goal of landing humans on the moon. Under von Braun's leadership, the Saturn V rocket was developed, capable of carrying astronauts beyond Earth's orbit. On July 20th, 1969, Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, fulfilling President Kennedy's vision of a moon landing before the end of the decade. The future of space exploration, the Cold War rivalry that fueled space exploration, eventually gave way to international cooperation. The International Space Station, ISS, became a symbol of global unity, with astronauts from different nations working together in orbit. Russian cosmonauts and American astronauts trained in each other's languages to ensure effective communication aboard the ISS. However, the landscape of space exploration is changing. With the retirement of older space programs, new private companies like SpaceX are leading the way in space travel. The focus is now shifting toward Mars, which has been considered a potential target for colonization for decades. Early telescopic observations suggested the presence of water on Mars, fueling speculation about alien life. However, space probes later revealed a barren, inhospitable world. Despite this, the discovery of underground ice deposits has reignited interest in manned Mars missions. NASA and SpaceX are currently developing plans for a human expedition to the Red Planet, though the timeline for such a mission remains uncertain. The big question: should humanity invest in space exploration, or should we focus on solving problems here on Earth? This debate continues, but one thing is clear. Our curiosity and drive to explore the unknown have always been at the heart of progress. What do you think? Let us know in the comments below.